we are going to learn how to construct a confidence interval for the mean when sigma is unknown. And since we'll be working with the t-distribution, we're going to use technology in this case, so statcrunch. The first case is when we're given data, so like an Excel file like this one. So in this example, the following data set includes a random sample of pulses of females in beats per minute and a random sample of pulses of males. Assume pulses are normally distributed. Use the data set to construct a 90% confidence interval estimate of the mean pulse of adult females. Round your final answer to 1 decimal place. So the first thing I'm going to do is I'm just going to click on the file, and then I am going to save it to my computer. Okay, and the next thing that I'm going to do is I'm going to open the file up in statcrunch. So now that I'm in statcrunch, I'm going to go to Data, Load, From File on my computer. Next, you can either drag the file or I'm just going to browse for it. And I open the file, and now I click Upload. Okay, so now I can see the data in statcrunch, and I'm going to hit Stat, T-stats. So that's the command you will use when sigma is unknown and you're estimating a mean. 1 sample, and I'm going to choose with data since I have the data. Next, I choose the column for females. I click on confidence interval for mu, and I'm going to enter the correct confidence level I'm interested in, and I hit compute. Here's my readout, and you can see that the lower confidence interval limit is 64.611, etc. So I would round that to 64.6. And the upper limit is 78.72, ... So I would round that to 78.7. So using statcrunch, the confidence interval I got was 64.6 beats per minute to 78.7 beats per minute. So I just want to show you how to interpret this correctly. Here are a couple ways. We are 90% confident that the mean pulse of adult females is between 64.6 and 78.7 beats per minute. Another way, using the margin of error, is we are 90% confident that by using 71.7 beats per minute to estimate the mean pulse of adult females, we are off by no more than 7 beats per minute. The last thing I want to show you is how to do essentially the same problem, but when we are given the summary data instead of the spreadsheet. Okay, so once again, we're going to construct a confidence interval for the mean. Sigma is unknown, so we need to use technology, but we're given summary data. So for example, a random sample of 15 female pulses has a mean of X bar equal to 71.67 beats per minute and a standard deviation of S equal 15.5134 beats per minute. So this is a sample mean and this is a sample standard deviation. We do not have the population mean, obviously, because that's what we're estimating, but we also do not have the population standard deviation in this case. Assume pulses are normally distributed and use the summary data to construct a 90% confidence interval estimate of the mean pulse rate of adult females. Okay, so in this case, how would we use statcrunch? So here I am back in statcrunch, and I'm going to click on Stat, T-stats, 1 sample, and with summary. Next, I'm going to fill in the sample mean that was given. And the sample standard deviation, which was and I will click on confidence interval and 90%, and the sample size was also given n equal 15, and I click compute. And here we have the lower limit and the upper limit of the confidence interval.